6. Adding, subtracting, and multiplying polynomials. So just like we add simple algebraic expressions and multiplication, same sequence will continue. X is variable, n is non-negative. These are A are constants, A and being the leading coefficient, the first one. A0 is the last term. The higher power of x in the polynomial is called degree of the polynomial. For
Sorry,
example,
I don't know why, but your volume is a little bit low, and my volume is up.
so degree of constant. If I just write this expression, so I will call it that the highest degree is 3. Degree is the highest power of x. Worked example, if p is given and q is given and the expressions for p plus q, so we are just adding the polynomials. I just find it easy when I write it above each other or even in the horizontal manner. So this is p plus q. 2x cube plus x cube is 3x cube. Let me do that directly. And then minus 6x, there's nothing in x square that stays as it is. Then there's nothing in x in both of them. So 1 is only in q, and minus 5 and minus 1 is minus 6. These were addition. In the same way, subtraction, we will change the sign of second. And then this is a constant multiplication. Let's try the fourth one, where we multiply the two polynomials. The first one is 2x cube minus 6x square minus 5 times the second one is x cube plus 2x minus 1. Before we multiply, the highest degree, the degree of p is 3, the degree of q is 3. Now we're going to multiply p into q. So the first one in all of these, 2x cube and x cube is 2x6. Then 2 times is 4x4. Then we have 2 1 times minus 2x cube. Now the second one with all of these. Minus x is minus 6x 5. 6 2 times minus 12 x3 and plus 6x square. Then the third one is minus 5x cube minus 2 minus 10x plus 5. And finally simplification. So 2x6, there's no other term. And then in power 5, there's only one term, minus 6x5. In power 4, this is 4. And this is the only term. Now in 3, I can see this and this in cube. That is, and this in cube. So 12 and 2 is 14 and 5, 19. 19x cube. Then we look at x square. There's only one single term. And in x again, minus 10x and the last constant. Now this would have a degree of 6, the highest power of x. So in the first exercise, we just have simple addition, subtraction, multiplication, and division.
Basically the same style of questions.
Yeah. Let's do one of these. For we didn't do subtraction in the worked example. Let's do that. And then we'll move on to further practice. 1c. P of x minus 2 times q of x. Okay. So P of x is 3x4 plus 2x square minus 1 minus 2 times q of x is 2x cube plus x square plus 1. The first one come out as it is. Now we multiply with minus 2. So we get minus 4x cube minus 2x square and minus 2. So there's no term in x4. 3x4 stays as it is. There's only one term in x cube, 4x cube. And then in x square, we have plus 2x square and minus 2x square would just cancel out. And the last thing is minus 4. A different writing style in question number 2. They're not giving it as functions of p or q. That is just directly given and expected to simplify. Find the following products. Let's try A and F. 2x minus 1 into 4x cube plus x plus 2. When we multiply 2x and all of these, this is 8x4 plus 2x square plus 4x minus 4x cube minus x minus 2. The only term in x4, then x cube, then x square, and in x plus 3x, and the last constant. Try F part.
So 27x cubed minus 27x squared plus 9x minus 1.
Okay, I was just thinking I will start with you. 3x minus 1 into 3x minus 1 whole square. So that's 3x minus 1 into a square minus 2ab plus b square. 27x cube minus 3 6 times 18x square plus 3x, and with minus 1 all the signs changes, plus 6x minus 1. So 27x cube minus 27x square plus 9x minus 1. Are we getting same answer?
Yes.
Okay. Now question number 3 is just a bit longer. 2 are multiplied and then added or subtracted. Let's go for question number 4. Okay. I think we should try all of these. These are different. F of x is given 2x square minus x minus 4. And g of x is given as x square plus 5x plus 2. And we need to find all of these. Let's copy them one by one. f of x plus x gx. Let's do this together. Let me know when you've copied f of x and g of x.
Okay. I got it. So for the first one, it's x cubed plus 7x squared plus x minus 4.
Yeah, we're getting same.
Yep.
Second one is f of x whole square. You know the difference between part B and part C?
Oh, so f squared x means that f is multiplied into f of x?
No, the B part means f of x is multiplied with f of x.
And then secondly, it's f is multiplied into f of x.
That is substituted in that.
Okay,
Uh,
so the x.
Let's do B first and then we'll look
Okay.
in for C. So this is simply the square. So basically 2x square minus x minus 4 whole squared. We'll write this 2 times.
Okay, so for b part, it's 4x to the power 4 minus 4x to the power 3, cubed, minus 15x squared plus 8x plus 16, right?
Yep.
Okay.
Now we have f square x. That is basically we substitute f in f. So when we have 2x square minus x minus 4 as f of x, we're going to substitute this in f. Basically 2 into f of x squared minus f of x minus 4. This is what we're doing. So 2, luckily we already have what f of x square is. We can copy that 4x 4 minus 4x cube minus 15x square plus 8x plus 16. 2x square minus x minus 4 and minus 4. Any confusion in the substitution?
No. Okay. I'm getting the same thing.
Okay. Division of polynomials. I think we can directly jump on the algebraic form. We know how to divide the numbers. And this is it. Let's just take a small example of numbers. For example, we are dividing 7 by 2. So 7 goes inside, 2 stays outside. This is 2, 3 times the closest number is 6, and then we subtract, and I'm left with 1. So we can write it as 3 whole and 1 by 2. And we can also write like 3 whole 1 by 2, a positive sign in between them over here. This is what we are going to do in the algebraic form. So let's say the polynomial given is x cube minus 5x square plus 8x minus 4, and it is divided by x minus 2. In a similar way, I need a number which I should write in the quotient. So to get x cube or the closest number, so I'm multiplying with x square. I'm just looking at the first number. We never look at the second one in this case, which is minus 2. So x multiplied with x square will give me x cube, and the remaining will give me minus 2 x square. Then we always subtract, we change the signs. This goes away, and we have minus 3x square. Sometimes it is enough to copy down one term, but I feel easy, copy all of them. Now, in order to get minus 3x square, I'm multiplying it with minus 3x. So x into minus 3x is minus 3x square. Same term because we change the sign and eliminate it. Then minus 2 into minus 3 is plus 6x. Now we change the signs and we get 2x minus 4. Now looking at the first one again, in order to get 2x, I'm multiplying with 2. So x into 2 is 2x, minus 2 into 2 is minus 4, and then we change the signs, subtract them, 0. So the polynomial x cube minus 5x square plus 8x minus 4, when divided by x minus 2, leaves an answer of x square minus 3x plus 2 and no remainder. When there is no remainder, I can also say that x minus 2 is a factor of the given polynomial.
So basically, if we multiply x squared minus 3x plus 2 with x minus 2, we should get
Yes,
the. Okay.
exactly. Should get the original factors, original polynomial back. Okay, this is another worked example. Let's just copy the question. 2x cube minus x plus 51, and it is divided by x plus 3. And let me just confirm the previous one is x square minus 3x plus 2, right? Try this.
So basically, I'm first multiplying the x plus 3 with 2x squared, and then that gives me 2x cubed, which I can subtract with 2x cubed. But then afterwards, it's 3x squared, and then that can't subtract with
That is
minus.
x square.
Oh yeah, 6x squared, and that can't like subtract with
That's
x, and then we just carry it down then.
yeah. When we will subtract it, basically we'll get rid of this, and we are left with minus 6x square minus x plus 51.
Oh, okay. So we just carry all of it down. Okay.
Yeah.
So when I go further, it's it's right now I'm at 2x squared minus 6x, and then the negative 6x squared cancels, and we're left with negative x plus 51
You multiply it with which number to get minus
minus
6x square?
6x.
That's right.
Yes. Oh, so the 18 turns to a plus. Okay. So then afterwards it would just be minus 17 at the end.
Plus 17. To get the same first term, then we subtract, so 0.
Okay.
2x square minus xx plus 17, 2x square minus xx plus 17. And we have a lot of questions to practice. Uh, Pick one out of question 1.
E.
Okay. So this is x cube minus 3x square minus 33x plus 35, and I'm dividing it with x minus 7. X square gives me x cube minus 7x square, and we change the sign as minus and plus. Cancels out, and this is 4x square minus 33x plus 35. When I'm getting 4x square first and 7 4 times is 28. Change the signs, that is minus 5x plus 35. To get minus 5, we multiply with minus 5 and plus 35. Change the signs, and that's 0. So the answer is x square plus 4x minus 5. Pick one from question 2.
D.
D, you said D, doctor?
Yes.
3x cube minus 21x square plus 4x minus 28, and we divide it with x minus 7. So 3x square minus 7 3 times 21x square. Sign changes. We are left with 4x minus 28. Get 4x, we just multiply it with 4. And 4 times 28. Signs change, 0. 3x 4 plus 4. Now, question 3 is just a different writing style. 3a and 3b are exactly same. Let's try 3c. 3x cube minus 50x plus 8. and then 3x square plus 12x minus 2. If both of these were quadratic, we would go for either midterm breaking or something and eliminate the like terms first. Three x cube minus 50x plus 8, 3x square plus 12x minus 2. So the first one first is into x. You get 3x cube, 12 into x is 12x square, minus 2 into x is minus 2x. Changing the signs, cancel out. There's nothing in x square in the first line. So I'm having minus 12x square. Then 2 of the x's, minus 48x plus 8. To get 12x square, I multiply it with minus 4. Minus 12x square. 12 4 times is minus 48x and positive 8. Change the signs, and that is 0. Try D part.
Sorry, could you scroll up?
Yeah, sure.
Oh, okay. Okay. So try D part.
Yeah. Question noted.
Yes. X plus 3.
X plus 3 is. Look at 4a. X4 minus 1, and we're dividing it with x plus 1. So x3 gives x cube plus x cube. Sign changes. This was 4. So we're left with minus x cube minus 1. Now looking at negative x cube, I multiplied with negative x square to get negative x cube and negative x square. Same thing continues, sign changes, and this is x square minus 1. To get positive x square, we multiply with x. That's x square plus x. Change the signs, and we're left with negative x, negative 1. Multiplying with minus 1 is negative x, negative 1. Sign changes, and finally 0. So the answer is x cube minus x square plus x minus 1. Okay, factor theorem. Now we just know how to divide it. So when we exactly divide something that is a factor, and if it is not a factor, we will be left with some sort of remainder. For example, I'm dividing 10 with 2 and I get 5. There's no remainder. So 2 is a factor of 10. And we know 3 is not a factor of 10. So when we divide 10 by 3, we're left with some sort of remainder. Or we write 3 whole, 1 over 3. So basically 3 completes and 1 remainder. Or we would get mixed number or fraction or something. So when it is a factor, there's no remainder. 10 divided by 2 is 5. There's no remainder. This is basically factor theorem. So when we divide the first expression with the second, we are getting this, no remainders. It is exactly divisible by x minus 2. So for a polynomial, if PC is equals to 0. Okay, now this is another way to just check it. If I go for this, let's say we started here. Okay. Now see, we were dividing with x minus 2. So x minus 2 equal to 0, x is equals to 2. This is another way if we have to avoid long division. But the requirement of this question was to find the quotient. So we had to go through long division. And x is equals to 2. So if I just put x is equals to 2 in the original polynomial, minus 5 into 2 square plus 8 into 2 minus 4. Because x minus 2 is a factor, we are always going to get 0 when we simplify. 2 cube is 8, 2 square is 4, 4 5 times minus 20, 8 2 times is positive 16 minus 4. 16 and 8 is 24, 20 and 4 is minus 24, we get 0. Because x minus 2 is a factor. Similar way, if I use this, x plus 3 is equals to 0, x is equals to minus 3. So I'm substituting minus 3 in the polynomial. See, minus 3 cube is minus 27, and 27 into 2 is 54, plus 3 plus 51. That's minus 54 and 51 and 3 is plus 54 and we get 0. Whenever we substitute the value which was the factor, we are always getting 0 as a remainder, or we say no remainder. If it was not the factor, we will always end up with some value. So that is one thing how we check it. And this is how we do. We always substitute it equal to 0 to find the value of x. This is not always going to be a single digit or simple addition. We could also have like 2x minus 1 equal to 0. So 2x is equals to 1, x is equals to 1 by 2. We may have fractions as well. And discuss with your classmates which of the following expressions are exactly divisible by x minus 2. Now we have 9 of these expressions. It would take very long if we go for long division and check if we get 0 as a remainder. So the other way is that we just write x minus 2 is equals to 0 and x is equals to 2. Now we would use our calculators and punch in these expressions and see where we are getting 0, and that is exactly divisible by x minus 2, and we would say x minus 2 is a factor. I'm using calculator and punching in 2 in the first expression. I'm getting 0. So this is a factor. Let's quickly try them where we would not get it as a factor. In the second one, I'm getting 25. Please confirm.
I'll try.
We just have to substitute x2.
Yeah, I'm just writing it out.
Okay.
Yes, 25.
Okay, now let's just see how it would look like if we would have done it through long division. 2x cube plus 5x square minus 4x minus 3. And we are dividing it with x minus 2. 2x square gives me 2x cube minus 4x square plus minus minus plus. Cancels out. This is 9x square minus 4x minus 3. With 9x, we get 9x square minus 18x. And the difference is 14x minus 3. So to get 14, you multiply with 14 is 14x minus 28. Plus to minus, minus to plus. Cancels out. And 28 and 3, difference is 25. This is the remainder. You see two different methods. Either we try this or we try 2x cube plus 5 into 2 square minus 4 into 2 minus 3 And what did we do? We substituted 2 and we're getting 25. Method 1, method 2. We only go for long division either when it is asked or when we have no other choice. Show that x minus 3 is a factor of this by algebraic division or factor theorem. So algebraic division is long division and factor theorem we just substitute the number if the question restricts. This is a good one. Question is that 2x square plus x minus 1 is a factor of 2x cube minus x square plus ax plus b. It says is a factor means remainder should be 0. We cannot substitute this in the given polynomial, so we're going to work that out. 2x square plus x minus 1, split it into linear factors. Product is 2 and sum is 1. 2x square plus 2x minus x minus 1, 2 common, x plus 1, minus 1 common, x plus 1. This was 2x. So 2x minus 1 into x plus 1. Quickly recheck it. Yeah. So basically, this polynomial is divisible by this thing, expression 1 or 2. The first one was written in quadratic form. The second is two linear factors being multiplied. So we use 1 by 1. 2x minus 1 is equal to 0. X is equals to 1 by 2. And the second is x plus 1 equal to 0. X is equals to minus 1. So first I'm going to substitute 1 by 2. This is 2 into 1 by 2 cube minus 1 by 2 square plus a into 1 by 2 plus b, and we write it 0 because it is already given, it is a factor, so remainder will be 0. 8, this is 2, 1 by 4 minus 1 by 4 plus a by 2 plus b is equals to 0. So multiplying the equation with 2 is a plus 2b is equals to 0. Equation 1. Then we do the same with x is equals to minus 1. 2 into minus 1 cube minus minus 1 square plus a into minus 1 plus b. That's 2 minus 1 minus a plus b equals to 0. 2 minus 1 is just 1. A minus b is equals to 1 is equation 2. Now we solve these two equations simultaneously. A plus 2b is equals to 0. I'm subtracting the second one. Minus a plus b is equals to minus 1. 3b equals minus 1. B equals minus 1 by 3. So a is equals to 1 plus b. 1 minus 1 by 3 is 2 by 3. So a equals 2 by 3 and b equals minus 1 by 3. Did some mistake. Oh my god. There it goes. Let me quickly do that. This was the mistake. This is minus 2, which makes it minus a plus b is equals to 3. That was minus 2. So the first equation is a plus 2b is equals to 0. Second is minus a plus b is equals to 3. We add them. 3b is equals to 3, b is equals to 1. And then a could be equals to minus 2b is equal to minus 2 into 1, a is equals to minus 2. A minus 2, b 1. Okay. Now it says use the factor theorem to solve this. It's not restricting for any method. So we divide it with x minus 4. That means x is equals to 4. I'm using calculator punching in 4 and all the numbers, all the x's. 4 cube minus 3 into 4 square minus 6 into 4 plus 8, and I'm getting exact 0. And this is a factor. Try D part. X is negative 1 by 3. I'm getting 0. Are you getting it?
I'm writing it out. Yes, 0.
The longest question or the maximum difficulty level is like the one we did in the worked example. We would get quadratic expression and we are dividing some polynomial, and we would have two factors and then two simultaneous equations which we could solve. It says find the value of a in each of the following, and it says is it is a factor. So when I'm looking at question 2a, this is 6x cube plus 27x square plus ax plus 8, and it says that x plus 1 is a factor, so value of x must be minus 1. 6 into minus 1 cube plus 27 into minus 1 square plus a into minus 1 plus 8. If it is a factor, it should be equal to 0. Minus 6 plus 27 plus 8 is equals to a. So 27 plus 8 minus 6 is 29. A is equal to 29. Similar way we solve the other parts. Get question number 4. Question 3. It says x minus 2 is a factor of this, express b in terms of this. So x cube plus ax square plus bx minus 4. And we are substituting x equals 2. 2 cube plus a into 2 squared plus b into 2 minus 4 is equals to 0 because it is a factor. 8 plus 4a plus 2b minus 4 equals to 0. We get 4a plus 2b is equals to minus 4. Express b in terms of a, making b the subject. 2b is equals to minus 4a minus 4 dividing by 2 minus 2a minus 2. Okay. Find the value of a and the value of b in each of the following. So again, it says it is a factor. In the preceding upcoming exercises, we would see that sometimes it is given that it is not a factor and we have a remainder. So just in place of that 0, we would substitute the remainder. Everything else would stay same. Try the first one. X cube plus ax square plus bx plus 30 is divisible by, or x square plus 3x minus 10 is a factor. It would turn into two simultaneous equations, and then we'll find a and b. I'll also start doing it.
For some reason, I feel like the answer I'm getting is not valid.
Not valid. Like
Yeah.
second part, x square plus 3x minus 10.
The value of a that I'm getting.
And what are you getting?
Getting 0.
Maybe. No issues. We'll just check. See, we have two simultaneous equations, and it is quite possible that it may intersect at 0. Let's just see.
Okay.
So this is 38. 4a plus 2b is equals to minus 38. And 4a, or just divide it with 2. This 2a plus b is equals to minus 19. Are you getting this as first equation?
Sorry?
Are you getting this as first equation?
2a plus b. Oh, I was getting 2a minus b.
Hmm. A
Okay.
positive, x is positive 2. What we substitute?
Okay.
30 minus 125 is negative 95, goes on the other side is positive 95. Divide the whole equation with 5 as 5a minus b is equals to minus 19. 2a plus b equals minus 19, and 5a minus b equals minus 19. Simply adding them, this is 7a equals to minus 38.
Then how did I get 0?
You just change the equation,
Okay.
and I'm getting this as fraction. We'll just quickly go through. X cube plus ax square plus bx plus 13 divided by x square plus 3x minus 10. Right, to the minus 10, I think we get 3. So this is 2 and minus 5. 2 cube plus 4a plus 2b plus 30 is equal to 0. That's 38 minus 38 divided by 2 is 19. Equation 1. And then when we use minus 5, 5 into 5 into 5 is 125, and negative 125, and 5 square is 25, and negative 5b and 30. 30 minus 125 is minus 19, minus 95. Goes on the other side, plus 95 dividing by 5 is 5, 1, and minus 19. 2a plus b equals minus 19, 5a minus b, we just add them. Okay, let's just continue with this. And I'm having b is equals to minus 19 minus 2a. Minus 19 into minus 2, minus 38 by 7. Using calculator, 38 divided by 7 into 2, getting 76 by 7, minus 19 is 57 by 7. Now, if these are correct, we should have remainder as 0. I'm copying the original question with these values. This was x cube plus ax square, where a is minus 38 by 7x square, b is 57 by 7x plus 30. Till now it seems so odd, these fractions, and we just got to know that these are the factors. So x is equals to 2. I'm using x is equal to 2. 2 cube minus 38 by 7 into 2 square plus 57 by 7 into 2 plus 30. 8, 38 into 4 is 152 by 7. 57 into 2 is 114 by 7 plus 30. And I'm not getting 0. There's a mistake. X square plus x cube plus ax square. Okay, that was cube and square. plus 30 divisible by x plus 3 minus 10. 5 to the minus 10 and we're getting 30, taking out common x plus 5 minus 2 common x plus 5, x is equal to 2 and x is equal to minus 5. 2 cube is 8, 2 to the 4, 2b plus 30. Minus 38, 2, 1 and minus 19. Minus 5 cube is minus 125 plus 25 minus 5b plus 30. Hmm. 30 minus 125 is 95. Minus 95 goes on other side. Oh my god. Why did I write minus 5? Minus 19. That was plus 19. This was plus 19. That was plus 19. So we get 7a is equals to 0, a is equals to 0. So 2a plus b is equal to minus 19. When a is 0, b is equal to minus 19. I can rewrite the equation with a 0 and b minus 19. The equation is x cube. A is 0, x square goes away, minus 19x plus 30. And the factors were 2 and minus 5. 2 cube minus 19 into 2 plus 30. And the other one is minus 5 cube minus 19 to minus 5 plus 30. 8 minus 38 plus 30, we're getting 0. So that means the values are correct. Minus 125, 19 into 5 is 95 plus 30, getting 0 again. So A and B are correct. Did you get it?
So A and B are both 0.
Yeah, A is 0 and B is minus 19.
Oh, okay. So A is 0, B is minus 19. Okay.
Okay. Let's try question number 7. It says x minus 3 and 2x minus 1 are the factors of polynomial 2x cube minus bx square minus 2qx plus q. Find the values of p and q. So x is equals to 3 and x is equals to 1 by 2. 2 into 3 cube minus p into 3 square minus 2q into 3 plus q is equals to 0. 27 into 2 is 54. P square is 9 minus 9p minus 6q plus q. 54 minus 9p minus 5q is equals to 0. Cohesion 1, and the second one would be 2 into 1 by 2 cube minus p into 1 by 2 square minus 2q into 1 by 2 plus q is equals to 0. 8 1 by 4 minus 1 by 4 p minus q plus q is equals to 0. 1 by 4 is equal to 1 by 4. P is equals to 1. 54 minus 9 into 1 minus 5q. 54 minus 9 is 45 is equal to 5q. Q is equals to 9. P1 and Q9. For B part, I'm rewriting it. 2x cube, P is 1 and Q is 9. It says x plus 3 is also a factor. Why x plus 3 is a factor, we'll just check. Because it would leave a remainder of 0 when divided. 3 into 3 into 3 is 27. Into 2 is 54. 3 square is 9. And 18 into 3 is 54. And this was negative 9. Plus 9. Negative, positive, negative, positive. So why is x plus 3 a factor? Because it leaves a remainder of 0. Okay. So far 4.1, 2, and 3. In your free time, I don't think you would have to go back to 1 and 2. 3 would give you enough practice of the exercises before this.
Okay.
So just practice few questions out of the remaining
Okay.
and you'll be good to go. The concept would stay same for cubic expressions as well, just the difficulty level is increasing.
Okay, so I'll look over that too as well.
Yeah, sure. We'll just save the time. Only the difficulty level is increasing. There would be one thing, like for example, question number 3, solve the following equations. You would need the first factor and then go for long division. Then you'll be left with quadratic. Then we can go for either midterm breaking or quadratic formula. So the first factor is always a hit and trial. If you just look at this, I'm punching and calculate, I'm using 1. Because clearly I can see that at 0 it is not a factor, it leaves 35. So I'm writing 1 cube minus 3 into 1 square minus 33 into 1 plus 35 and I'm getting 0. That was just a luck that I got it in first time. Maybe it would have been 2 or 3 or minus 1, minus 2 or minus 3. So what we do is we just punch in. So I'm getting 0 with x is equals to 1. That means x minus 1 is a factor. So I will go for long division. X cube minus 3x square minus 33x plus 35. I'll divide it with x minus 1 and get a quadratic factor here. Then I'll split this into 2 and finally I'll get all the 3 factors. So first of all 4.3, the remaining exercise, and then if you get time look at 4.4 as well.
Okay.
Anything you would like to ask
No.
this? So we already know the roots. Question number 8. It says minus 2, 1 and 5. This actually means x is equals to minus 2, x is equals to 1 and x is equals to 5. Would you agree?
X equals minus 2? Yeah. And 1 and 5.
Now, one step before this would have been x plus 2 equal to 0,
Yeah.
x minus 1 equals to 0, and x minus 5 equals to 0. And one more step back would be x plus 2 into x minus 1 into x minus 5 equal to 0. That's how you are going to get a polynomial. So f of x is product of these three: x plus 2, x minus 1, x minus 5. Now this is self-sufficient, a complete polynomial equation, but if we have to simplify in cubic form, we'll just multiply. So first 2 is x square minus x, then plus 2x minus 2, x minus 5. So first is x square plus x minus 2 into x minus 5. Now we multiply x cube minus 5x square plus x square minus 5x minus 2x plus 10, x cube minus 4x square minus 7x plus 10. So from roots, we got the polynomial in reverse order.
So, okay, I understand what you did, but I don't understand how the question is asking us.
F of x is a cubic polynomial where the coefficient of x raised to power 3 is 1. Okay, it is cubic and 3 roots are already given. When f of x is equals to 0, basically it's factorized this. F of x is equal to 0 and that was cubic root. Let's say ax cube plus bx square plus cx plus d is equal to 0. So we are looking for a, b, c, d. And after all the working steps, remember we found the first factor by hit and trial method and then long division and then quadratic
Yeah.
formula.
Yeah.
This is basically reverse of that. Roots are already given and we are finding the equation. Let me say it was a quadratic equation and x is equals to 2 and x is equal to minus 3. So this would have been like this. So f of x would be equal to x minus 2 into x plus 3. So x square plus 3x minus 2x minus 6. This is x square plus x minus 6. So
Okay.
we've been this and we substitute it equal to 0 to find these. So basically reverse of that.
Okay.
And
And that's the
same
same for question.
for all the questions.
But for question 9, it says the coefficient of x cubed is 2. So that 2 is in front of x cubed.
Let's try this. It says f of x is a polynomial where the coefficient of x cube is 2. Find f of x when the roots of f of x equal to 0. Okay. So x is equals to negative, I'm writing negative 1 by 2. And x is equals to 2 and x is equals to 4. Now, if I just, there are two ways. I can write x plus 1 by 2 equal to 0, right?
Yeah.
But the hint is already there that x cube, the coefficient is 2. So in spite doing this, I'm multiplying this 2 on the other side. 2x is equals to minus 1 and 2x plus 1 equal to 0.
Okay.
And this is x minus 2 equal to 0. And this is x minus 4 equal to 0. Now we multiply these three. So f of x is equals to 2x plus 1 times x minus 2 times x minus 4. So first 2x square minus 4x plus x minus 2 and then it is x minus 4. So 2x square minus 3x minus 2 and x minus 4. 2x cube minus 4 2 times is 8x square minus 3x square plus 12x minus 2x plus 8. So 2x cube 8, 9, 10, 11 minus 11x square plus 10x plus 8. That's cubic polynomial with coefficient of x cube as 2.
Okay. So we just have to make one of them with the coefficient of 2 and then multiply them together.
Yes.
Okay, and then question 10 is the top line is the same. The second line, the roots of f of x equals 0 are negative 3, 1, square root 2.
Process. Just the difficulty level is increasing.
Oh, okay, it's still the same 3 roots. But then what about 1 minus square root 2?
So basically roots are like this. X is equals to minus 3. Solution 10. And it says x is equals to 1 plus square root 2. And x is equals to 1 minus square root 2. Okay. I'm just having a quick look. B square minus b plus minus b square minus 4ac over 2a. So the result is this. Let me just follow the exact same method. This was the f of x is a cubic polynomial with the coefficient of x cube as 1. So x plus 3, and we take this on the other side. This is x minus 1 minus square root 2 into x minus 1 plus square root 2. That's okay. Look closely. I'm multiplying the right side first. I'm considering this thing as 1 and square root 2 as the other thing. Now see, if I just consider x minus 1 as one thing, minus square root 2, this is the other part, and x minus 1 again, plus square root 2. May I think of this as a
Yeah.
minus b into a plus b?
Yes.
So x plus 3 is there, so a minus b into a plus b is actually a square minus b square. So x plus 3, a square is a square minus 2ab plus b square, and this is 2. So x plus 3 into x square minus 2x plus 1 minus 2 is minus 1. X cube minus 2x square minus x. Now with 3 plus 3x square minus 6x minus 3. X cube square and square is plus x square. X and x is minus 7x minus 3.
So it's basically the same steps, just a little bit more work.
Yeah, the difficulty level is a bit more. Exact same process.
And then 11 is the same.
Yeah, same way.
What about 12?
2x plus 3 is a factor of this. Okay. When 2x plus 3 is a factor, that means 2x plus 3 is equal to 0. X is equal to minus 3 by 2. So we can substitute this value and put it equal to 0 because it is a factor, so there is no remainder. So you can just substitute value of x as minus 3 by 2 in the complete equation and then equate it with 0.
Okay. And then it says So how do we? So after we find the value for that, how do we show that? And then we just
Hit and
plug the value again for a.
yeah, hit and 12. That's a cubic polynomial. Shall I do it?
Yeah.
Okay. Now it says 2x4 plus a square plus 1x cube minus 3x square plus 1 minus a cube times x plus 3. Now we just said that x is equals to minus 3 by 2. X is equal to minus 3 by 2. So 2 into minus 3 by 2 raised to power 4 plus a square plus 1 into minus 3 by 2 cube minus 3 into minus 3 by 2 squared plus 1 minus a cube into minus 3 by 2 plus 3 equals to 0. I'm using calculator. 2 into minus 3 by 2 raised to the power 4 is 81 by 8. 81 by 8 plus, now this is minus 3 by 2 cube. It gives me negative 27 by 8. Negative 27 by 8 a square plus 1. Now this is minus 3 into minus 3 by 2 squared gives me negative 27 by 4 plus that is already minus 3 without power. Minus 3 by 2 into 1 minus a cube plus 3 is equal to 0. 81 by 8 minus 27 by 8 a square minus
I'm
27 by
confused
8.
about why we got the -3/2 in the second step.
Why we got that? Because the factor was 2x plus 3.
Yeah, no. I mean before 1 minus a cubed, -3/2.
Yeah, when the factor is 2x plus 3, we get value of x from here.
Yeah. But you see, it's plus 3 equals 0, and then before that, it's -3/2, 1 minus a cubed.
1 minus a cubed.
No, below that.
Okay, this is 1 minus a cube.
No, below, like the third line.
Starting with green.
Yeah, green, but then the blue part of green. Yeah,
That's not. I've just rearranged it, nothing else.
okay.
That was the constant, so I just brought it to left hand side.
Okay.
So 1, 2 multiplied minus 3, and this is minus 3 by 2 plus 3 by 2 a cube plus 3 is equals to 0. I'm going to handle all the numbers at once. Number, 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 and number. So 81 by 8 minus 27 by 8 minus 27 by 4 minus 3 by 2 plus 3 is 3 by 2. Now I have a square and nothing else. A cube is 3 by 2 a cube minus 27 by 8 a square is equal to 0. May I just multiply the complete equation with 8 to get rid of the denominators despite taking the LCM? If I would just multiply this is 12 plus 12a cube minus 27a square is equal to 0.
So we multiplied, I know we multiplied negative 27 by 8 to get negative 27, but then what about 3 by 2 and 3 by
Yeah, we just even if you would take LCM,
it would still
get
be
rid of
8.
the denominator. Then at the later step, the denominator would go on the right hand side and multiply with 0.
Okay. So 3 by 2 and 3 by 2 is cubed. Okay.
Now all these are divisible by 3. This is 4a cube minus 9a square plus 4 is equals to 0.
Do we have to show that we took 3 out of it?
Now that's understood.
Okay.
Like you don't have to write this 1 by 3.
Okay.
Now this is A part that's done. B part says find the possible values of A. So 4a cube minus 9a square plus 4 is equals to 0. I'm using my calculator and going for hit and try. This is not an option. So I would substitute such a number that I should get 0. So I'm trying 4 times 1 cube minus 9 times 1 squared plus 4. So with 1, I'm getting negative 1. I'm trying 2. With 2, I got 0. Basically, A is equals to 2. 4 into 2 cube minus 9 into 2 square plus 4. So I'm getting 0.
Okay.
That is my first factor. So it would be A minus 2 and 4a cube minus 9a squared plus 4
Why is it a minus 2?
because this was my factor. So reverse of that.
Oh, so it was
Many.
a minus 2 equals 0.
Yeah.
Okay.
Now we go for long division. So when I'm dividing this, I need 4a cube. So I will multiply it with 4a square to get 4a cube. Now that negative 2 into 4 is negative 8a square. And the rule is sign changes, plus minus, minus plus. We cancel that. This is negative a square. We just bring that down. Now to get negative a square, I can multiply it with negative a. So that's negative a square minus minus plus 2a. Sign changes. Now we get rid of this. That's minus 2a plus 4. To get minus 2a, I'm multiplying it with minus 2. So minus 2a minus minus plus 4. And we change the signs. That's 0. 0 also confirms that there's no mistake. So basically now this cubic polynomial could be written as product of these two. 4a square minus a minus 2. Now this is 4 into 2, 8. I cannot think of any other factor, rather 8 into 1 or 4 into 2. And adding, subtracting 8, 1 is not giving me 1. 4, 2 is not giving me 1. So going for quadratic formula. So a is equals to basically minus b plus minus square root b square minus 4ac over 2a. It won't contradict, so I'm just not writing it. That's minus 1 plus minus square root minus 1 square minus 4 into a is 4 and minus 2 over 2a. 1 plus minus square root, that's 4 into 4 into 2 is 32 and 1 is 33. 33 by 8. So basically A is equals to 2. A is equals to 1 plus square root 33 by 8, and A is equals to 1 minus square root 33 by 8. Find the possible values of A. So these are three values of A. Any doubt?
No, because we just have to factorize it. Okay, so for the test on tomorrow, I was just thinking of doing topical past papers when I was like self-studying. That's okay, right? That's good.
Yeah.
Okay. And when I was doing topical past papers, I came across questions where logs and stuff were included and where we had to do topics from like chapter 11 and stuff.
If like that definitely depends on the content of the exam. If it is part of
Yes.
the exam, definitely we'll have to go through it. Or for now, we can skip. That
Okay.
was chapter 3 and 5, right?
Yeah,
Inequality.
indices and surds and inequalities, equations, and graphs.
Yeah. Ultimately, we'll be covering everything. So for now, if you are having any parts which includes logs, you can skip them.
Okay, but for my test, I asked my teacher, and he said, um, you would just give me like a past paper, a topical past paper on them. And he said, whatever is on the topical past paper, you should be able to do for the units.
Yeah, yeah. Topical. They would actually select those questions out of those topics.
Yes, but when I found topical past papers for these units, they included logs and units, chapters, like topics from chapter 11 and stuff.
So you shouldn't worry about that. If your teacher knows that they've asked you to solve this questions, for example, AP study y equals mx plus c straight line equations.
Yeah.
Straight line graphs also include logs. L x square, we do convert them. So they realize, yes, the concept is used in those topics as well, but they won't give you an exam because they know you've just started it.
Okay. For example, should I share like some topical past papers to show you?
Yeah, sure.
Okay.
You send it as email.
Yep. Okay, I sent it.
First one is just inequality modulus.
Yeah, but
Substitution, third, fourth, fifth. Where it says do not use calculator in this question, in question 5, basically you have to show each and every step. You will be having your calculator with you.
okay. But like questions like let's say question
7.
1 4 or yeah, question 7 where there's logs and
By using substitution, y is equal to log x to base 3 or otherwise find the values of x. You don't have to worry about that. First of all, this is 3y square plus 5y minus
y.
this is 2. Last one is 2.
Oh yeah.
Actually, that does not include x. This is logarithms. They won't give you this.
But I asked my teacher and he said yeah, this would be included.
No, they would say that logs are included because you need to know the rules of logarithms for this. Say
I
this says 3 log x to base 3 whole squared plus log x raised to the power 5 to base 3 minus log 9 to base 3 is equals to 0. And the question says use substitution y is equals to log x to base 3. We may have different things in different topics, but still you have to study logarithms for this. Now this is 3, but purely that's y as given. Substituted. Now this is 5, this can come down as power rule. So this is 5 log x to base 3. Now how would you know that that's power rule? You need to study logarithms before attempting this. This 2 would
and
now
the
come
last
to
one, yeah. And the last one is let's say 3 to the power of what equals to 9, so that would be 3 to the power of 2.
So now this is 3y square plus 5y minus 2 is equal to 0. Now we will solve for y. This is now a quadratic equation. 3 2 times minus 6. 3y square plus 6y minus 2 is equals to 0. 3y common, y plus 2 minus 1 common, y plus 2 is equals to 0. Now 3y minus 1 and y minus 2. So 3y minus 1 is equals to 0, y is equals to 1 by 3. On the other side, y is equals to 2. And y was equal to log x to base 3. So I can write log x to base 3 is equals to 1 by 3. So x is equals to 3 raised to the 1 by 3. On the other side, log x to base 3 is equal to 2. So x is equal to 3 raised by 2. That is 9. These are the two values.
So x can either be 3 to the power of 1/3 or 9.
9, yes. But you need to study logs to attempt this. That was substitution, yes. But for logs. This won't be on the test
Okay.
unless they tell you.
Sorry?
This won't be on test unless they tell you that logarithm is included.
They haven't told me logarithms are included, but my teacher said that like questions like this would be on it.
Like these or like logarithms.
with logarithms.
That's unfair. Like, I mean, we can't expect you to complete like chapter 3, chapter 5, and logarithms 3 chapters in 1 week.
I don't know. I'll tell him about it. I'll tell him that I'll email him as well, and I'll tell him that logarithms should not be on the test because I don't know the properties for them. But then also question 1-4, because I was doing this, but then it didn't match with the one I did on the marking scheme.
Question number 1.
4.
Question
One
4.
part 4. No, 1 part 4.
Okay. Hence, find the values of x for which this does this have to do anything with the previous parts or separate? It is sort of linked. If you see the very first line, that's 2x minus 5.
Yep.
And just multiplied with 9. So right hand side is 9y already. Why is this? Okay. So it says on the axis below, sketch the graph of these two. Let's consider that we've done. Solve this is equal to 4. From graph, we can do that too, and individually we can do that. Hence, show that the graph of this and this intersect at the points where y is equal to 4. So we would just substitute 4 and get same values of y. Hence, find the values of x for which this is equals to this. Okay, so when y is 4, so we can just solve them individually because
So
at that point, let me just try that quickly. This is 80x, like 9y is equals to 80x minus 16x squared. And when y is 4, is equal to 80x minus 16x squared. So I'm rearranging. 16 comes on left hand side is 16x squared positive minus 80x plus 36 is equals to 0. And we can divide all of these with 4. This is 4x squared minus 20x plus 9 is equals to 0. 4 9 times is 36, and 36 is either 1 into 36, 2 into 18, so 2 and 18 could be adjusted. 4x squared minus 2x minus 18x plus 9 is equals to 0. We take out 2x as common, so I'm left with 2x minus 1 and minus 9 common, so 2x minus 1 is equals to 0. 2x minus 9 into 2x minus 1. So 2x minus 1 equal to 0 and 2x minus 9 equal to 0. So we get 2x is equals to 9, x is equals to 9 by 2, and 2x is equal to 1, x is equals to 1 by 2. Are these same or different?
with the marking scheme.
Yeah.
Okay. I can't find it right now. I did this like a week ago, week and a half maybe. I'm gonna try and find it.
Just take a screenshot, probably will be helpful.
Sorry?
Just take a screenshot. You can like compare it later.
Okay.
That would be helpful. This is it.
Okay. And then also there was another question. Oh yeah, can we also do a question 2?
On the topical paper.
Yeah.
Sure. The one which says do not use calculator.
Yeah, do not use a calculator in this question. Because
So
this was the question where we had to do something from like chapter 11 or something.
seven, I'll just. Okay, it says find the positive solution of the equation this. 5 plus 4 square root 7 whole. This is x square plus 4 minus 2 square root 7. That's x minus 1 is equal to 0. It says find the positive solution of the equation this. Giving your answer in the form a plus b square root 7, where a and b are fractions in their simplest form. And it is 5-point question. So we are not using calculators. And I can see that this is a quadratic equation.
So
But
we
this
could just
is a,
formula, right?
this is a, yes. So minus b plus minus square root b square minus 4ac over 2a. So minus b is 4 minus 2 square root 7 plus minus square root 4 minus 2 square root 7 whole square, e square minus 4, and a is 5 plus 4 square root 7, and c is minus 1 over 2 into 5 plus 4 square root 7. Now that's minus 4 plus 2 square root 7 plus minus, and this is a square minus 2ab, 2 4 times 8, 8 2 times 16 square root 7 plus b square. 2 square is 4, a root square is 7, 7 4 times 28. And minus minus is plus 4 plus 20 plus 16 square root 7 over 10 plus 8 square root 7 minus 4 plus 2 square root 7 plus minus, and now we just collect these numbers. This is 16, 28 and 20. 16 plus 28 plus 20 is 64, and negative and positive cancels. This is 10 plus 8 square root 7. Now this is square root 64 is 8 minus 4 plus 2 square root 7 plus 8 at 10 plus 8 square root 7, and the other one is minus 4 plus 2 square root 7 minus 8 over 10 plus 8 square root 7. Let's finish one first. Adding these two is 4 plus 2 square root 7 over 10 plus 8 square root 7. I was thinking about taking out common, but I realized that won't be cancelling it all, because in common and denominator is just 2, so that would be 5 plus 4. So we'll rationalize it. This is 4 plus 2 square root 7 over 10 plus 8 square root 7 times 10 minus 8 square root 7 over 10 minus 8 square root 7. Now the numerator is 4 into 10 is 40 minus 4 8 times is 32 square root 7. Now 2 into 10 is 20 square root 7 and 2 into 8 is negative 16 and into 7 divided by a plus b into a minus b is a square minus b square. B square is 8864 into 7. Now simplifying the numerator, which is 40 minus 16 into 7 gives me negative 72 and minus 32 and 20. The difference is 12 square root 7 by 100 minus 64 into 7 is negative 348. And now we just write them like this. And I can use calculator to simplify. 72 divided by 348 is 6 by 29 plus 12 by 348 is 1 by 29.
But without
And
calculator, how would I simplify them? Like, not the first one, the second one I'm talking about.
yeah, this part, like the second last step,
Yeah.
basically without using a calculator is actually with you on at all times and during the exam. Without using calculator means you have to show each and every step.
Oh, okay, so we can just use it to simplify.
Yeah.
Okay.
So this side is done. Now the other side. So that's minus 12 plus 2 square root 7 over 10 plus 8 square root 7. We rationalize into 10 minus 8 square root 7 over 10 minus 8 square root 7. Now this is
Yeah,
minus 120.
rationalization, so that's further into the book, right?
Mm, yeah, sort of. Like that's not a very big task, but definitely the difficulty level of this question is higher, so we have to go through a lot of working.
Okay.
Should I complete this?
Yeah.
Okay. So 12 into 10 is 120 and minus minus plus 12, 8 times is 96 square root 7. Now 10 into 2 is 20 square root 7 and 2 8 times is negative 16 into 7. And denominator, I could just copy that this would be 348 because the denominator on left hand side is same. So that's negative 348. Now we solve these numbers 120 and minus this. So 120 and 16 times 7 is 232. Whereas 96 plus 20 is 116 over 348. Now we'll simplify that again. 232 by 348 plus 116 square root 7 over 348. 232 by 348 is 2 by 3 and 116 by 348 is 1 by 3. So these are our two different answers in form of a plus b square root 7.
But I believe in the marking scheme there was only one. And I believe
Because it
it's
says
positive.
positive. Yeah, positive. So this is the one.
But why is it positive?
Because when you solve, these two are pure positive, plus 6 by 29 plus square root 7 by 29.
Yeah,
The
but why are we rejecting the negative one?
Because the question says that write positive only.
Oh, okay. Okay. Can we also do question 10?
Let me open that. This one with the curve.
Yeah. So for the f of x, a, we just need to find the roots and then solve it from the roots.
Let's see. Okay, the curve is given. The diagram shows the graph of f of x, where f of x is a cubic polynomial. Find f of x. Okay. So a rough sketch. It passes through -5. It passes through -1, and it passes through 2. -5, 1, and 2. But first of all, I need to remember that this was positive x cube, and this is definitely negative x cube's graph. So x is equal to -5, x is equal to -1, x is equal to 2, x plus 5, x plus 1, and x minus 2. F of x is equal to, and there you go, a negative sign, because this is negative x cube graph. Now I'll simplify for f of x. I'm keeping that negative outside for later. This is x square plus x plus 5x plus 5 times x minus 2. Negative stays outside. X square plus 6x plus 5 into x minus 2. So x cube minus 2x square plus 6x square minus 12x plus 5x minus 10. Negative x cube plus 4x square minus 7x minus 10.
Couldn't we just leave it at?
Right?
So I think f of x is finding the values of x, right?
No, they were already given. Finding f of x is the finding the polynomial.
Oh, okay.
This, like the equation of the curve. Finding f of x is finding the equation of the curve.
Okay.
So the equation of curve.
Okay, and then b.
B says write down the values of x such that f of x is less than 0. Neat sketch. This is clearly -5. This point is clearly -1. And this is 2. Now the question says f of x is less than 0. Is this the region where f of x is less than 0?
Yes.
And this.
Yep.
So may I say f of x is less than 0 for -5 is less than x is less than -1?
Yes.
And when x is greater than 2,
Yes.
that's done.
Okay. Okay. I think, yeah, I think this question was actually okay. I think I actually said the wrong one. I meant 9. Yeah, 9 part 2.
Let me see.
Because it has exactly 2 solutions, and I could only figure out the one.
Okay. Let me just go through. On the axis, we'll sketch the graph of this, showing the coordinates of the points where the graph meets the axis. Find the values of k for which this is equals to k has exactly 2 solutions. Let me quickly sketch a part.
Okay.
So question 9 says y is equals to mod of 2x square minus 9x minus 5. So I'm going for completing square form because either we go for turning point and find the value y or completing square. I'm just ignoring the modulus part and solving completing square. So this is 2 common, x square minus 9 by 2x minus 5 by 2. Then that's 2 there, x square minus 9 by 2x. Half of coefficient of x is 9 by 4 squared minus 9 by 4 squared minus 5 by 2. And 2 stays there. This is x minus 9 by 4 whole square minus 81 by 16 minus 5 by 2. 2 stays there, x minus 9 by 4 whole square using calculator. 81 by 16 and 5 by 2 gives me 121 over 16. And now we bring in that 2. So 2 into x minus 9 by 4 whole square minus 121 by 8. So if I go for this sketch, I can see that the turning point is x 9 by 4 and y negative 121 by 8. So positive x and negative y. And I can see that there is positive value of a, so it is a smiley face. I need to see when x is 0, what is y. So this is 2 into 9 divided by 4 squared minus 121 divided by 8. So when x is 0, y is minus 5. So basically it cuts at negative y-axis. This point is minus 5. At this point is 9 by 4 comma negative 121 by 8. And now I'm going to find the point of intersections. These 2 points where y is 0. So 2x minus 9 by 4 whole square minus 121 by 8 is equals to 0. 2x minus 9 by 4 whole square is equals to 121 by 8. Dividing by 2 is x minus 9 by 4 whole square equals 121 by 16. Taking square root on both sides gives me x minus 9 by 4 is equal to square root of that is 11 by 4, and x minus 9 by 4 is equal to negative 11 by 4. 9 by 4 plus 11 by 4. 9 plus 11 is 20 by 4 gives 5. So that's 5, and x is equal to negative 11 by 4 plus 9 by 4. 9 divided by 4 minus 11 divided by 4 is negative 1 by 2.
So the
So
way that you found 2 brackets x minus 9 over 4 squared minus 121 over 8, that's just
yeah,
factorizing it, right?
that is completing square form. That was one method. There are other methods too.
Could you scroll up?
Yeah.
Yeah, so you took the 2 out, and then we completed the square, and then we got 2. Okay. So the value inside the brackets is the x value, and then the
Yes.
value outside is the y value. And then the
We
x
already
value changes
changed the
sign.
sign for it.
Okay.
Okay. So now this is the sketch. I'm just bringing it down. Let me quickly bring it for working
Oh,
space.
sorry. Before we move on to part 2, I remember
Yeah.
there being like rules or like ways that you have to follow when you're sketching the graph, where if it's a certain um exponent that it's being multiplied by, it's either going to go through the line or it's going to curve at the line.
Yeah, that's what I did. Before sketching, I just checked where it would intersect. For example, if you had values here like x2 and y8 and it is a smiley face, you don't need to check, you would just sketch because you are very sure it would be cutting at the positive x-axis. But when it is below, and it's a smiley face. Now I'm not sure it would intersect at this one position in blue, or it would pass through zero in green,
Mm,
and the third
what I
one in
mean
black.
is, for example, can you go to question 11A? Just like an example.
11A, in this test. Okay, yeah.
So, for example, x minus 2, that would be with like 3,
No,
x minus 2
this
cubed,
is different.
and
Let's
then,
keep it.
yeah, but then wouldn't that cube mean that it would go through the line? And then if it was square, then it would mean it would
I'll show
curve
you. I'll show you.
that line?
Just copy this. I'll show you. This is
Okay.
5. This is negative 1 by 2. And this is 5 again. Minus 5. Okay. See, when you have y is equals to x minus 2 and x plus 1 and 3 minus x. First of all, can you just see through it as positive x cube or negative?
It's positive.
It's positive. So this needs to be like this, and exaggerated form would be like this.
But
So
if it's positive, doesn't that mean that all of the values in front of x have to be positive? But the last
no,
one,
no,
tell you.
those are just the point of intersection. Positive x cube would just decide the shape.
No, I mean deciding whether it's positive or negative from the way it's written. I saw
We are
people.
not looking at these numbers. No, this is actually negative. I just see
Yeah,
this negative x.
so it's
So that's
negative.
negative. This
Yeah.
is going to be the shape.
Okay.
Now this is x2 for sure. This is x3 for sure. And that's x minus 1. Now if I have to make this shape, it will pass through 3, it will pass through 2, it will pass through 1, and for sure y intercept is negative. And when we need to find that, we just substitute x 0. So that would be minus 2 into 1 into 3. So that's negative 6. And done.
Okay.
All the
But
intersections, their shape is there.
but I mean when there is one, let's say x minus 2 is cubed, that would mean that it goes through the line. But if it was squared, wouldn't that mean that it curves out the line and doesn't go through? Or isn't there like rules similar to that when we're graphing?
Okay. Now x minus 2 cube. Let me just quickly check it. I've just updated it. I think I lost it. Let me check. Okay. So basically that simple x cube, there's no element of x square in it. So that is just deciding the movement. For example, if it was only x cube, this would be my graph. And when it is x minus 2, it moves to right. When it would be x plus 7, it will move to left. Just like this. And if it is just x minus 2 whole square, that's quadratic. That's an entirely different topic. And yes, this minus 2 would directly tell me that it intersects at 2. When it is like x plus 5, this would tell me that it intersects at minus 5.
Okay. But if they were written together like question 11A.
I think we just talked about this equation a bit, but definitely when we'll be doing this topic, actually we are doing mixed chapters, sometimes 5, 3, 4, we're jumping across them.
Yeah.
If we would cover that, A has its role. A positive means smiley face. A negative means sad face.
Okay.
H comma K has their role. This is turning point. This is H comma K. H goes up, the graph moves left. H goes down, the graph moves right.
What does it mean goes down?
Like, for example, if this is H, if I just write x minus 3 whole square plus 7, and then I write x minus 5 whole square plus 7, see the value of H is decreasing.
Yeah.
So the graph would move right.
Oh, okay. Okay, so if there was two different ones.
Yeah.
Okay.
When k increases, the graph goes up. When k decreases, the graph goes down. So all these numbers have their role. There are rules, and we could just imagine the exact graph without drawing it. Because when we are looking at it, I know the turning point is 3 comma 7, and it is a smiley face, and it is like this x3 y7, and this is how it would look like. And we can find the intercepts x or y axis, whatever they are, by substituting x equal to 0 and y equal to 0. Shall I complete this?
Yeah.
Now this is done in modulus. When you put modulus across it, this will give you this graph. This is how it would look like. Somehow needs to be symmetric. So the one in black,
Yeah.
modulus. Now this value is plus 5, and this is x stays same, y jumps over. So 21 by 8. Now the question for B part question 9. It says find the values of k for which modulus of k has exactly two solutions. Now see, if I just draw the line here, how many solutions am I getting?
Then values below 5, right?
No, no, no. Like it is intersecting at four different points. One, two, three, four.
Oh, okay.
So I'm getting four solutions, right?
Yeah.
So when I will draw a line at the x-axis, it is basically again four solutions. And when it goes up, this is four. When it goes up, this is four. When it just crosses the point where the turning point is, this again is four solutions. And when it just leaves it, it would be two solutions, like here. So may I say that when k is equals to 121 by 8, it is having four solutions. And when k is greater than 121 by 8, it is two solutions.
Yes.
So this is your answer.
So k greater than 121 by 8. But
Yeah.
that's only one solution. What's the second
But
one?
four. Sorry, those are two solutions because it is intersecting at 2 points.
Yeah, but it's isn't it asking for the value of k?
Yeah, that's the value. It is a range. When k is greater than 121 by 8, we have two solutions. It says find the values of k for which it has exactly two. So these are the values of a
Could
121.
x squared minus 9x minus, because I knew one of the solutions was 2x squared minus 9x minus 5 equals to 0. That was one of the solutions. So k equals to 0 is one of the solutions.
That cannot be, because at 0 we are having four solutions.
But at the marking scheme it was.
The turning point actually, see if I just draw it like this and I say this is 2 and I say this is minus 1, would you write x plus 1 into x? minus 2 into x minus 2. So at the x-axis, this turning point is actually counted as two solutions.
Okay.
And in particular, if we are just like looking at values of x, so yes, at x is k is equals to, so this would be at like k when it is greater than 121 by 8 and when it is equal to 0. In particular, we can say that yes, this is one value of x, this is other value of x.
So wait,
That
I
is,
don't understand. So it could be either greater than that, but it could also equal to 0.
I'm still like lingering on k greater than 1 by 121 by 8.
Okay. I just remember the solution being k equals to 0 and another value. And I'm 100% sure it was k equals to 0.
Then they're just taking it in the concept that if we have to write the value of x, there will be two, like 1 minus 1 by 2 and 5.
Sorry?
They're taking that in this context that when k is equals to 0, there are only two values of x, that is 5 and negative 1 by 2. So that's why taking k is equal to 0 is possible.
I don't think. Oh, I don't think I understand. So,
I'll check this further. Exactly two roots. This part is for sure, no doubt. And if you just remember that they are considering that at k is equals to 0, we are having only two unique values of x. It is minus 1 by 2 and 5.
yeah.
No third value. So that's why they're considered as 2.
Okay.
Any other question in this?
No, I don't have any more.
Okay. Is school sharing this? Like,
No, I
top,
found it myself.
like someone just compiled it.
It's from a website.
Yeah, that's written at the
Yeah,
bottom.
it's from a website My Study Compass, and I just searched up IGCSE Math topical past papers, and then because I wanted more practice, so I found these, and then afterwards I saw like logarithms on them and stuff, and then I asked my teacher, and he's like, "Oh yeah, that's also gonna be on it." But he didn't say the unit was gonna be on it because I asked him, "Is the unit gonna be on it?" He said, "No, the unit's not gonna be on it. It's indices and surds and equations, inequalities, and graphs, but
Hmm.
logarithms are also going to be on it." Which makes I don't know. So that's why I'm gonna email him.
Okay. Maybe they could share some topicals with you to be more specific.
Okay. Well, my test is tomorrow.
Hmm. Don't worry. I'm sure it would be reasonable within the syllabus limits.
Okay. Let's start
Anything else for today?
nothing else.